In this video, we will be going over some of the basic elements of a chilled water system. The topics include the purpose of a chilled water system, parts of a chilled water system, plate frame for cooling, plate frame for reheat, system pumps, multi-pump, multi-chiller systems. We will also be talking about the chilled water system sequence of operation and condenser sequence of operation. Chilled water system is to provide cold water to air handler equipment for the purpose of cooling supply air to control space temperature. Water is cooled to a predetermined set point that is set within the chiller itself. The water system will contain the evaporator side of the chiller, which is the area where the water is cooled. This section contains the primary pumps, the secondary pumps, which move water to the air handlers. The condenser side of the system is the area of the system that pulls the heat off of the chiller itself. As these machines run, they generate a lot of heat that has got to be removed from them. The cooling tower is part of the condenser side, which actually removes the heat from the condenser water loop. The tower bypass valve is used to regulate the temperature of the condenser water. If the condenser water gets too cold, the machine can have problems. If the condenser water gets too hot, the machine can have problems. It must be maintained within a set point of design by the manufacturer of the chiller. In shot, we can see the primary side of the chill water system on the left hand side of the screen. Of course, the chillers are located in the middle. On the right hand side of the screen is the condenser side. This particular unit also has a plate frame heat exchanger. We also see the cooling towers as well as the condenser sump reservoir. It has a plate frame heat exchanger configured for cooling. Will provide chilled water to air handlers by using cooler outside air temperature to cool the water. The condenser water flows over the cooling tower to be cooled by outside air. That water is then flown through the heat exchanger to help cool the chilled water. In this screenshot, we see a typical layout for the plate frame for cooling. On the left-hand side of the screen, we have our primary pumps. We also have oscillation valves for when the plate frame system is used to isolate the chiller from the system. The plate frame for cooling is generally used during the colder months of the year and is a good source of providing cold water to the air handlers. The plate frame heat exchanger is shown below at the bottom of the screen. You can also see how the heat exchanger is tied into both the primary side of the chill water system as well as the condenser side of the chill water system. On the condenser side, there is some type of antifreeze added to the water to keep the water from freezing during extreme cold temperatures. The water that is flown over the cooling tower is cooled by the outside air. That water is then pushed through the plate frame heat exchanger by the condenser pumps, and on the other side of that heat exchanger is the chilled water that is pushed through the heat exchanger by the chill water pumps. That water is then pushed to the air handlers by the primary chill water pumps, or in some systems a secondary chill water pump, just depending on how your system is configured. A water system that has a plate frame heat exchanger configured for reheat uses the heat generated by the chiller to provide heat for the hot water system. Heat that isn't pulled off of the machine by the plate frame system is pulled off by the cooling tower. In the photo, you can see a plate frame heat exchanger on the left hand side as well as a chiller on the right hand side. This is a very efficient way to provide hot water for a reheat system. In this graphic, we see the typical layout of a plate frame system configured for reheat. Unlike the system that is configured for cooling, the plate frame system on this unit is used to heat the water for the hot water system. One of the drawbacks to this type of configuration is when the outside air temperatures are at a level where the chiller itself is not needed. When the temperature reaches that level to where the chiller is not needed, then you will need to provide some type of a backup heating system, either a boiler or steam system. Pump systems only have one chilled water pump that moves water through the chiller and the air handlers. Multi-pump systems have primary chilled water pumps and secondary chilled water pumps. The primary chilled water pumps provide flow through the evaporator side of the chiller. The secondary chilled water pumps pull the water from the primary loop and distribute that water to the air handler. The condenser pumps flow the water over the cooling tower to remove the heat from the machine. In the system shown by this graphic, we have one chiller that is served by two primary chill water pumps. We also have two secondary chill water pumps, as well as two condenser water pumps. The purpose for having so many pumps on this system is due to the redundancy of the system in a critical area. If one pump were to fail, we could lose the entire chilled water system. In a system configured like this, we have the option of simply switching to another pump to keep the system online. Multi-chiller systems are generally designed for system redundancy. These types of systems are generally found in critical areas such as science buildings, medical complexes, that sort of thing, where if one system or one part of the system fails, another part can be brought online to keep the entire system running. Some systems will have multiple pumps as well as multiple chillers. These systems are often configured in a lead-lag system, which allows for either pump combination to be run with any type of chiller or any one of the chillers. The fixed pump systems will only allow for a specific pump to be run with a specific chiller. Part of the chill water system sequence of operation is the chill water system lockout set point. That set point is a temperature value that is the point at which the chiller is either enabled or disabled. It is very helpful to set the chill water lockout to the same value as the economizer set point of your air handlers. Whenever the chill water system comes up, we disable the economizers of the air handler, close to outside air to allow the system to be cooled by the chiller only. When the outside air temperature reaches or falls below the chill water system lockout, the chill water system is disabled, allowing the outside air to be used through the air handler to cool the building. Whenever a chill water system is enabled, the pumps will always start before the chiller. It is very important that those pumps are up and moving water through that machine before the machine itself is enabled. When the system is disabled, the chill water pumps are shut down last. We must maintain flow through that machine for a period of time prior to the entire system being turned down. We need to keep that water moving, because if you let it get too cold in that chiller, it can damage the machine. We need to keep it running long enough to help move some of that cold water out of the machine. Side of the chill water system, when the water reaches a specific set point, the system will react to help keep the temperature from getting too hot. Generally, if the condenser water gets too hot in the system, the chiller can go out on a high head pressure. A high condenser temperature can damage the machine. Most chillers do have some type of a safety which is designed to protect them. The cooling tower bypass valve, whenever the system is equipped with one, will open flow to the tower which will flow the condenser water over the cooling tower and remove the heat from that water. The cooling tower fans help to push air through the tower to additionally cool the condenser water. A plate frame system, if one is equipped in your system, will also help to pull the heat from the condenser loop. I hope this video gives you a little better understanding of the components of a chill water system as well as how they work. If you have any questions, please feel free to drop me a comment. Also visit my blog at systemcontroltech.com. And thanks for watching the video, and leave me any comments down below. Thanks again.